finding z-score from the known areas. So what we are doing now, we will find a z-score and we will be given the area or the probabilities. Before I start this, let's understand what we have been doing so far. Let's write that. So far what we have been doing. So far what was happening, we were given a z-score. We were given the z-score and we were finding the areas or the probability, the same thing. Now we do exactly the opposite. We do the opposite. It's important that you understand that. And what is the opposite? The opposite, we are given the areas or the probabilities, and we will be finding the z-score. So this is exactly the opposite what we have been doing so far, right? So this is very important. This is very important that you understand this one, that what we have been doing so far and what we are doing now. Okay, before we start that, it's very important we understand this particular expression. This is very important. This notation is very important. The expression z sub alpha denotes a z-score with an area of alpha to its right. That's important. What I mean by that, let me write that. When I write here a z sub alpha, what does this mean? This means I'm talking about a z-score. I'm asking what is the z-score? What is the z-score so that alpha is the area to its right. That's important. It's right? The picture will make the things clear. What I mean by z sub alpha. Let me show you a picture. I have a normal curve like this, and I'm interested in the z-score. What is the z value such that the alpha, such that this area is alpha. So this is important that you understand this notation. Z sub alpha means tell me the z-score, give me the z-score such that alpha is the area to its right side. And recall from our earlier discussion, the total area under the normal curve is always equal to 1. If the area on the right side is alpha, then clearly the area on the left side will be, this area will be 1 minus alpha. This area will be 1 minus alpha. Why this will be 1 minus alpha? Because the sum of these two areas will be equal to a plus 1. So if this area is alpha, then this area will be 1 minus alpha. So this is the basic stuff you need to understand. Now the things will become more clear when we do an example. So let's see an example. Find the value of z 0.025. It means you are asked to find the value of the z-score such that the area to its right side is 0.025. Let me make a picture, and the picture will make the things very clear. So what do you mean by z of 0.025? It means you are asked to find the z-score such that the area to its right side is 0.025. Let me make a picture here. We are asked to find a z-score, this one, such that this area is 0.025. That's what is asked. You have to find a z-score such that this area is 0.025. Now if this area is 0.025, then clearly this area will be 0.9750. This area, this one, the area on the left side, this area on the left side, the one I am shading in green, that area will be equal to this one. How I get this area? Because 1 minus 0.025 is equal to 0.975, right? That's what it is. Now what we're going to do, we're going to locate this value in the body of the table, of the normal distribution table. That value we're going to look for. Let's go to that table. This is the table for the normal probability distribution, and we are trying to find the value, or what we are trying to find, we are trying to find this value 0.9750, and we try to look at this value in the body of the table, and we are able to find this is the value 0.9750. We were lucky and we were able to find the exact value. So the question that comes to the mind, let's say if we are not able to find this value, exact value, then what we should do, we try to find the closest entry in this body of the table. I repeat, we were looking for this value 0.9750. let's recall that where it was this one, 0.9750. so we went to this table and we found this value in this body of the table, and luckily we were able to find the exact entry we were looking for. If we don't find the exact entry, we try to find the nearest entry, but now in this case we were lucky. So what we are going to do now, we're going to find the value, the z-score, right? What is the z-score corresponding to this one? It's 1.9, and on the top is 0.06. So the z-score comes out to be z equals to 1.96. So we are able to find this value that we were looking for. Z of 0.025 is equal to 1.96. Now the same computation can be done by using Microsoft Excel, and the command is equal sign norm.inv, inverse, and you provide the argument and it will give you the z-score. How we are going to do that? Let's see in Microsoft Excel. Here is in Microsoft Excel we are now, right? What we are going to do, we are going to go to the formulas, more function, and a statistical function, and here we are, norm.inv. These are all written in alphabetic order. Norm.inv. Select this one, and now you have to provide the probability. Probability mean what is the area to the left of that z-score. So this is very important. It's mentioned also. This is also mentioned here what he is looking for in every text box, right? So what is the area, right? He is asking for. The area was 0.9750, and he is asking for what was the mean. The mean was 0 and the standard deviation was 1, right? So the answer comes out to be 1.96. It would have been even easier had I done it like this, another way. You could have gone to the formulas, more function, statistical function, and you would have found norm.s.inv. I'm giving you the both of them, and just to tell you the difference, you will realize what is the difference. So norm.s.inv, norm.s.inv. Look at this one. In this, it's quite easy. He's just asking for the probability, which is the right way to go. Norm.s.inv mean, this function means give me the z-score for a standard normal curve. That happened to be a standard normal curve, and in this case the area was 0.09750. You enter this area and the answer will be this one. I have to round it to a two decimal place. Remember, we always round the z-score to the 2 decimal places. Always we do that. We always round a z-score at 2 decimal places. You get the same answer, right? So whatever the formula you apply, you are good with that. So you can use technology, or you can use the hand computation. It doesn't matter. You will get the same answer. Now we discuss more examples. A variable is normally distributed that has a mean of a 6 and a standard deviation of 2. Find and interpret the 85th percentile, the 3rd quartile, which is also called the 75th percentile. Okay, how we're going to deal with this problem? Let's see one by one. So in the first problem, we are asked to find the 85th percentile. So first recall, what is a percentile? A percentile are the data values which divide our data sets into 100 equal parts. The word percentile comes from the word percent. It divides our data into 100 equal parts, the percentile. And what is the 85th percentile? 85th percentile is a value such that 15% of the values are above it and 85% of the values are at or below that value. That we have to find. So we have to find the 85th percentile. P85 is required. How we're going to start this problem? How we're going to deal with this problem? Let's start. A variable is normally distributed. So that's a starting point. It means I have to start by drawing a bell-shaped curve. Let's draw a bell-shaped curve. This is a bell-shaped curve. Exactly in the middle, write the mean value, and also indicate mean value is 6 and the standard deviation of 2. Now the 85th percentile, that value will be somewhere here. That value will be somewhere here. That's the value we are looking for. And what happens? What happens that this area, this 85th percentile, it means 15% of the value are above and 85% of the value are at or below that value. So this area will be 0.15, and this area, we use a different color, and this area, this area will be 0.85. Okay, so actually what we have to find, if we make a normal curve, let me convert this into a standard normal curve. What we have to do, what we are asked to do, it's like this. This is the z-score. First we have to actually find the z-score. I'm trying to tell. This area is 0.15, and we have to find this area now, such that this area is 0.85. So in this problem, our first job is to find this z value. That's our first job. That's our first step in this problem. So actually what I'm going to do now, I'm going to compute z of 0.15. What is the z-score such the area to its right side is 0.15? That's what I'm going to find. Okay, for this purpose, I have to go to the table. Let's go to the table. So now we're in this table of a normal probability distribution, and we were looking for recall, we were looking for 0.15. We were looking for, z of 0.15. We have to find the z value such the area to its right side is 0.15. But this table won't help you, because this table only help you if you provide the area on the left side. It means if the area on the right side is 0.15, the area on the left side will be 0.85, 0.85, this one. And now we try to find this value of 0.85 in this body of the table. And look at that, this is the nearest value. We are not able to find the exact value, but rather we are able to find the closest value. And I told you in our earlier video, if you are not able to find the exact value, we try to find the nearest value. So this is the nearest value. This is not the nearest value. This is the nearest value. So what we are going to do now, we're going to find the z-score. Look at the z-score. The z-score will be, here it is 1.0, and at the top it's 0.04. So our z-score in this situation, our z-score comes out to be z equals to 1.04. That's the first step. Now what we are going to do now, we have to find this x value. This is the x value we have to find, right? Because this is a non-standard normal curve. This is the standard normal curve, but this is the non-standard. We have to find the x value. So what we are going to do, we are going to use this transformation. Let me apply this formula, z equal to x minus mu over sigma. Okay, that's what we are going to do now. We are doing the cross multiplication, little algebra. So we have x minus mu equal to sigma z, or x will be equal to mu plus sigma of z. I have done just small little algebraic manipulation, nothing more than that. Now I plug in the value, it's a 6, and sigma with the standard deviation was 2, and it was z was equal to 1 point. Let me clear that. That's not right. This was 1.04. So if you do this calculation, the answer comes out to be 8.08. So this is the value. This is the value of which is the 85th percentile, 8.08. What this value means? It means 85% of the values are at or below 8.08, and 15% of the values are above 8.08 in this particular situation. That's what the interpretation is all about. That's what interpretation is. So 15% of the values are above this value, 8.08, and 85% of the values are at or below this value. Now let's move to the part number 2. We have to find the third quartile. Remember the quartiles, they divides our data set into 4 equal parts, and the third quartile is also the 75th percentile. I have drawn the normal curve, and exactly in the middle I have taken the mean and the standard deviation. I have to find the 75th percentile. It means I have to find a value such that 25% of the value are above it and 75% values are below it. So I have shown this area in the red, in the 0.25. This area on the left side is 0.25, and this area in yellow is 0.750, right? 7.75, simple. So what I'm going to do first, I'm going to consider a normal curve here. Look at this normal curve. This is the normal curve, and I'm going to take the standard normal curve in this situation, which is the mean is equal to 0 and the standard deviation of 1. And I have to find the z-score such that this area, I have to find this z-score such that this area is 0.25. Now recall, if this area on the right side is 0.25, then this area on the left side will be the green area will be 0.75, as I have shown in this previous diagram. This area will be 0.7500. So what we are going to do now, we are going to find this value. We're going to locate this value 0.75 in the body of the table. How are we going to do that? Let's see. So we are in this table and we are trying to find the closest entry, the entry which is close to 0.7500. But you note that we don't find the exact entry, rather we find these two entries, and out of these two entries, this entry is the closest one to the 0.7500. So we now note down the value, what is that value is, look at this value. This turns out to be 0.6 here, and from the top it turns out to be 7. So the z-score comes out to be, 0.67. So here is the z-score. So we were trying to find out the z-score. So the z-score comes out to be 0.67. Okay, but now once we have found the z-score, now we will find the x value by using this formula. We have a z equals to x minus mu over sigma. We will do a little algebraic manipulation. So we will have x minus mu equals to z sigma z, and this implies that we have x is equal to mu plus sigma z. Now you plug in the values. Our mu is 6, sigma is 2, and z we have just found is 0.67. If you do this multiplication, it comes out to be 7.34. So this is our x value. So x is equal to 7.34. So this is the 75th percentile. It's 7.34. How we are going to interpret this? We're going to interpret this values like this. 30, 50, 25% of these values, the 25% of the values are above 7.34, and 75% of values are at or below the value 7.34. So this is very important that you understand how to interpret this one, how to interpret the 75th percentile. Again, 25% of the values are above 7.34, and 75% of the values are at or below 7.34. So I hope you understand. Thanks for watching.